we've covered the concepts with regard to how we're going to have a series of devices interconnected using 802.1d, but what I want to do is I want to spend a little bit of time talking about the aspects of other types of spanning tree solutions. Now, I mentioned that we would talk about MST and the breakaway, but what first I want to do is I want to, again, go through the illustration or the concept of what's happening, because remember, we started with CST. CST was 802.1d, to which Cisco created their own protocol of PVST+. PVST was the start out, but when they wanted to support some of the advanced trunking features, they ended up moving over to the plus. Now, the industry looked at a number of features that Cisco had integrated. Those solutions were things like loop guard, port fast, things like backbone fast, things like uplink fast. And the industry looked at this and they said, we love all of this, but still, Cisco's still insane. They got this idea of 1 to 494 VLANs. So what they did is they went through the list of what they liked, took this, took this, and they continued to ignore this. So what ended up happening was the industry standards body created a new protocol. They created 802.1w. Now the way I remember this is rapid spanning tree. The way that I actually remember this is I think of Elmer Fudd. It's WAPID. So 802.1w stands for WAPID spanning tree, and as long as you have that image in your head, you'll never forget what it stands for. Now when we look at this, what happened was Cisco took a lot of these features and patriated them to this particular protocol in version and enhancement. Now the main reason for doing this is because they wanted to incorporate those modifications. Now in doing so, Cisco decoupled the idea of, remember I told you that we would always have this idea of listening, learning, and then there's also other states, there's blocking, okay, and William's constantly pointing out the fact that disabled is a state, and it is. So there, I finally said it, William. Are you happy now, man? But the main goal that we wanted to do is we wanted to actually come through here and we wanted to decouple these from our port states. We also wanted to make another change. We want to make certain that the BPDUs are not sent just by the root bridge. Oh no, I'm just playing with you, William. William's like, yeah, sorry. All right, I'm ex-Army. I play kind of stiff sometimes. But yeah, I mean, the cool thing here is that we want to constantly be able to interject our color to the class, because that's the benefit of it being a live class. If it was just a recording, it would just be me talking to the camera. So as we go, oh, okay, yes, he's saying he's very happy that I mentioned it. Okay, he understood it in kind. But the main thing here is these BPDUs are going to be sent from our devices, all of the devices participating. And what we're going to also find is we're going to have some significant acceleration in our layer 2 domain. Now, here's the issue. The reason that this isn't really that big of a deal or a standalone topic is the fact that the configuration is just so stinking simple. So right now, I'm going to take myself out of the equation. Let me drag this over so it's a little bit better positioned so we can see everything. And what I'm going to do is on this switch, all I did was I created a new configuration. And I did that by typing right erase. Then what I ended up doing is I typed delete vlan.dat, hit enter, and then I reloaded. So all this did is just bring my device back up and make it operational. So as we look at this, and as we're starting to do our integration, all I want to do is look at what kind of spanning tree we'll have. So show spanning tree, and I want to look at VLAN 1. Actually, no, let's do this. Let's look at summary. So show spanning tree VLAN summary. What we're going to see here is this PVST mode. Now, if I want to change my operational mode, all I have to do is come up here and say spanning tree mode and use the context-sensitive help. Don't fat finger it and hit the enter button at the same time. And we're going to see our options. We have PVST. That, ladies and gentlemen, is indicative of PVST+. All right. We have MST, which is what we're going to be talking about next. That stands for multi-instance spanning tree, sometimes referred to as MIST. But what we want to call our attention to here is rapid PVST. Now, one of the things I want to do before we do this or implement it is I want to make certain that we at least look at the contents of one of our spanning tree tables. So let's do show spanning tree VLAN 1. And what we're going to see here is all of the information associated with our instance of IEEE compatible spanning tree, which is going to be the per VLAN spanning tree plus. Now what I'll do is I'll change it. I'll say spanning tree, and I'm going to say mode, and I'm going to say rapid PVST. That's all there was to it. So now let's repeat the show command and let's take a look at the differences. Well, we don't see a whole lot of difference, but what difference we do see is going to be important to us. Notice right now we have states. We have point-to-point and we have shared connectivity. In order for me to have a point-to-point connection, I have to have full duplex operation between my switch and my host. Now, here I've got on 11, for some reason, I have a shared operation. Now, notice my costs have remained the same. Nothing is really implemented with regard to 19, so let's scroll down all the way to the bottom. And what we're going to see now is that we have the same costs, and we also have another value right here, STP. Now, when we look at this, what we're going to recognize here is exactly what William is saying. We have this idea with the shared. What we're doing is we're using about a 10 meg connection operating in half duplex. 90% of the time it's going to be 10 meg, but it could be just sufficient for it to be half duplex. Because unless we have full duplex, we do not have the capability of absorbing collisions. Therefore, this can't be considered a point-to-point connection. Not by the PVST configuration at the very least, or rapid PVST in this instance. Now, what I want to talk about is this. I want to talk about this STP. Now, STP here is indicating to me that I'm communicating to a device that doesn't speak rapid PVST. So it's not running any of these optimizations, it's not running any other information associated with our config, and we need to understand exactly what's involved in that process. So when we look at this, what we have, the net effect right now is I don't have anything. I'm just running, I just picked a particular device. So I just picked Cat 1. Now what we're going to see here is, let's see, unless something happens, so do show interface trunk. Don't have anything there. Do show interface trunk. Don't have anything there. Do show interface trunk. Don't have anything there. And on Cat 4, do show interface trunk. So I'm not running any type of trunking configuration. So what I want to do is I want to change this. What I'm going to do is I'm going to enable every trunk port that we have. I'm going to come up here and say interface range, except for the gigabit. So I'll say interface range 19.224, switch port trunk incap.1q, switch port mode, and what we're going to say is we're going to say trunk. We're going to make everything static. I'm going to say no shut just in case, which is kind of obsolete, but it's still something I have a tendency to do on a regular basis. And then what I'm going to do is I'm going to say do show history. And what I'm going to do is I'm going to copy this entire config out, and I am going to put it on all of my other devices. So Cat 1 or Cat 2, Command V. Cat 2, Command V. And lastly, Cat 4, Command V. So now when we look at this, end, show interface trunk, what are we going to see? We're going to see that everything is up and trunking on all of our lines, that we are currently running 802.1q for our encapsulation type. We're using mode on, but let's take a look at one of these ports again, just to drive home the rest of the conversation. And that's going to be show interface FAO 19 switch port. And what I want to point out here is we're still running DTP. So manually configuring the port to operate as a trunk did not turn off DTP. If I wanted to turn off DTP in this instance, I would have to do switch port no negotiate. Not necessary for this configuration. The other thing that I want to do is I'm going to configure Cat 1 as our root bridge. So what I'm going to do is I'm going to come up here and I'm going to say spanning tree for VLAN 1 through 4094, and I'm going to say priority 4096. So now what we've got, we should be show spanning tree VLAN 1, and we should be the root bridge. which we are. Now, beyond this, what I want to do is I want to enable VTP because I don't want to have to fiddle fart around with my configurations of VLAN. So we'll say VTP. We're going to say that we're going to operate in the mode. Actually, we won't even change the mode. We'll say VTP domain IP expert. I want to come in here and say VTP version. And notice that we have version 1, 2, and 3 here. So what I'm going to do is I'm going to say version 3. Okay, now when we go through here, it's going to look like it's going to bark at us for a little bit, but let's see what happens. All right, now I know we didn't really cover version 1, version 2, and version 3 outside just some loose conversations, but I'm just going to put it in here because it's a feature we haven't used yet. The other thing is I want to turn on VTP pruning. Now we've got some issues here. Notice that I have domain mismatch information that's coming through here. It's coming through on different ports because of a VTP domain mismatch. Now, that's not something that's necessarily going to bother me because what I'm going to do is I want to create some VLANs here. I'm going to say create VLAN 100 to 110. And I'm going to hit enter. And notice here it says VTP VLAN configuration not allowed when device is not the primary server for the VLAN database. Now, what ends up happening here is in VTP version 3, we can create several iterations of servers. But what we're going to do is we're going to set up a primary and a secondary. I just wanted to be able to illustrate that because when you guys get some time, you might want to explore it. I'll share with you some different website information that you can go to, and I intend on blogging on this specifically in the next couple of days, well, after this particular boot camp. So all I'm going to do right now is I'm going to change this back to VTP, and I'm going to say that it's going to be version 2. And now let's see if we can create the VLANs. And exit, and notice it allows me to create the VLANs. We would have had to have done some auxiliary configuration using VTP version 3. And what I want to do is I'm going to, like I said, either do a blog or record a video blog for it and also add and modify some of the VTP routing labs or VTP labs that we have in the workbook. So looking at this, we've got this idea of our config. Now what I want to do is see and show if any of these VLANs, what's going on here? And show VLAN brief. See if any of those VLANs showed up in our config. And we can see that they are right here. So VLAN 100 to 101. Let's take a look at our configuration. Show VTP status. And note that we have IP expert as our domain. We're currently running in 2. We're capable up to 3. And here is one of the things I want to point out. Notice the advertising information. This is local updater, which means this update came from a device, and that device has no valid interface configured. Now what I want to do is I want to point out the fact on Cat 1, which should be our root bridge, and we're doing all of these updates, so we're treating it as our primary server, that update should have been sourced from a loopback interface. But if we come into the config on Cat 1, we're going to see that we don't have any interfaces. So show interface or show IP interface brief. Now I have no IP addresses configured on any interface, nor am I running any SVIs. However, I do have the capability of configuring a loopback. So let's do that. Config T, interface LO0, IP address, and we're going to say 172.16, and I'm going to say 07/24. Now let's take a look at this. Show IP interface brief. I'm going to exclude anything that does not have an IP. So exclude anything that is going to be unassigned. Do BRE brief. So now I see this address 172.16.01. Notice it's up and it's up. It's a loop back. So let's see what happens now. So if I come back over here to say Cat 4 and repeat my command from previous, actually not here, it was on what, 3? No, it was on 2. We'll do it anyway. Show VTP status. Now what we're going to see here is the system is going to have no record of an update because we haven't sent an update. Now update will come in time, it'll refresh, it'll do its thing. But what I'm going to do is I'm going to say no VLAN 105, or let's say 115. Exit. Now let's come over here and take a look at what's happening. Even now, let's see, did we synchronize? So we've got 16 here. What do we have here? Show VTP status. Here we have 16. Show VLAN brief. See if 105 is in the list or 115 is in the list. Well, it didn't exist. Now, the reason I'm doing this is that sometimes we want to force the scenario. We want to go in and do a configuration that's going to cause us to write to the database. However, what you have to understand is an operation that does not correspond to the necessity of being able to send an update will not generate that output. So all I wanted to do was kind of refresh it and force it, but what I did is I deleted a VLAN that didn't exist. So in other words, it made no change to the database, therefore I never had to send out any type of update. So what we're going to do is we're going to pick on VLAN 101 now. So we'll come in here and we're going to delete VLAN 101. It's going to be no VLAN 101, exit. Now let's see what happened. Hopefully we'll see a change in our database. Notice now it's 15, and now notice that it says last modified by 117.16.01. Now we still don't have a local updater ID. Why don't we have a local updater ID? Well, when we come over here to Cat 1, show IP interface brief, no, show VTP status, the local updater is the IP address that we're using. Now let's go ahead and create another IP address. Let's say interface, config T, interface, and what I'll say is LO1 this time, and I'll say IP address 192.168.07/24. No shut. And let's add VLAN 101 back. VLAN 101, and what I want to do is just simply add it back. So now what we'll do is we'll cut over to here and take a look at the output of our information. Now notice we're still receiving the updates here. We have the number of existing VLANs. We have 3. Let's see if we have 101 now. Show VLAN brief. And 101 is now back. Now what I want to point out here is very quickly before we move to the rest of this, is I can come in and go config T and I can say VTP, and I can actually specify, an interface that I'm going to use for my updates. So right now if I come in here and say I want to use LO1, interface, the name of the interface providing, hold on here, make sure I've got this right. Sorry about that. This is the reason I'm pointing this out is that the show command, the context sensitive help here is virtually useless because they just come up here and say word, and every once in a while even I forget about it. Now what we're doing is we're using this for information. Avery's asking, so does it source the updates from that interface or only use it as the ID? It only uses it as the actual ID. So this is my way of ensuring that I know who did what update. So if I come over here, and let's take a look at Cat 3. No, we'll do Cat 4. So config T, interface LO0, IP address, we will use 172.16.0.10.255.255.255.0, no shut. And then I come in here and I say, I want to create a VLAN. So we'll say VLAN 100, no, we'll say VLAN 666. We'll put the devil's VLAN since it will stand out for us. Exit. All right. Then let's cut back over to Cat 1. Show VLAN brief. Do we see 666 in the mix? Yes, we do. And when we come in here and show VTP status, what are we going to see? We're going to see that the last update came from 10. So all this is kind of a way for me to use the equivalent of a router ID in the context of the systems. And VA, yeah, I understand switches with version 12.2.4.4.6E6, SE6 are not V3 capable. I just got finished yelling at tech support they were supposed to get the version that I have, because I want to upgrade everything to 15, but I want to have one that's going to run stable, 15 code running on the devices that we have. And until I find one that I'm happy with, we're going to be running the version that I have, which is going to be show version, and that's going to be this idea of 12 to 55 SE6, so that we get all of the features that are actually they're in testing in this version, but they're live in 15, but we still get them. So I'm hoping that that's going to happen after hours today when we leave. I also wanted to double check. We're supposed to quit early today. What was it? Was it 6:30 that we said that we would dive out, so that we had 2 people that had appointments this afternoon? That fits really well too, because again, I'm going to have to get involved with tech support again tonight. It looks like we've got the majority of the routing issues fixed, so we're going to be taking care of the switches this evening. So someone, what version will be in the tested? What's going to be in the configuration portion of the lab? Is that what you're asking, William? It'll be 15. It'll be 15.0, which is the version that I'm going to run on our gear. It's just the main goal here is that I want to make absolutely certain that we have one that's not going to crash on us halfway through.